Usually at some point in our algorithms, we'd like to be able to change a value, calculate a new value, or just plainly modify values. And for that we need variables. And before we look at how we're going to use them in a wrangle, let's look at what they are. The kind of old school analogy of what a variable is this index card here, which has got a name, the variable name, in this case some name, and attached to it a single value, in this case a float value. So you could look up this index card, take it out of your index card drawer, and look up this value, and maybe even modify it. Put it back into your drawer. But here's what's actually happening. The data we're working on is in our computer's RAM, and behind a variable is a pointer to a defined location in your computer's RAM. In this case, the variable someName points to the location of this value that the variable stores. So the simple way of thinking about a variable is, it is just a shorthand pointing to some location in your computer's memory where you store one single value. So to be able to use a variable inside of Vex, the first thing we have to do is declare a variable. That means we'll have to tell Vex how we'd like to call a variable and what data type it should store. And the syntax for that is straightforward. You first write down the data type you want the variable to store, and then the variable's name, and finish your line with a semicolon, as always. So in our case, we are declaring an integer variable called someName_a with the line int someName_a semicolon. And this syntax remains the same across all data types. So for example, here we declare a float variable, here we declare a 3-dimensional vector, 2-dimensional vector, and 4-dimensional vector. And here we declare a variable containing a string. We can also declare multiple variables of the same type in one single line by using this syntax. In this example, we are declaring 3 float variables called someName b, c, and d with just one line. And the way that works is writing down our data type, then the first variable name, then a comma, second variable name, comma, third variable name, and so on until you've declared all your variables, and then again finish the line with a semicolon. Be warned, however, that you cannot give your variables any name there is. So a legal variable name may only consist of capital letters, small letters, the underscore character, or digits. And there are further rules. So the first character of your variable name should be either a letter of the alphabet or the underscore, but not a digit. There are no spaces or commas allowed in your variable names, and no special characters except the underscore. And also do not try to use reserved words like if, then, else as a variable name, as Vex will try to interpret them as other parts of a language, and thus will spit out an error message. So now that we declared the variable, we might run into problems, because currently our variable is not initialized yet, so we don't know for certain which value it has. And although Vex provides a safety net for this, there are languages in which you could run into huge trouble when trying to use an uninitialized variable, because currently we're just telling our computer, okay, my variable, let's call it a, is a pointer to this location in RAM. And this does not necessarily mean that this location in RAM is cleared or reset to any sensible value. It can store data from previous calculations or from other programs that used this part of RAM previously. So it would be hugely unsafe to assume that by only declaring a variable, it is also set to some sensible value, like for example 0 in most cases. However, Vex usually automatically does that, yet it is good practice to also initialize your variable, which you would do with this syntax. You just put down the variable's name, drop down an equal sign, and then write its value that you want to set it to. And usually you do all this in one line of code, so it would look like this. And here you are declaring and also initializing your variable to a value of 17.85 in our case. That being said, Houdini's safety net is that as soon as you declare a new variable, Vex will automatically take care of setting it to 0. Nevertheless, it is good practice to initialize your variable while declaring it. Here are some examples for declaring and initializing some other types of variables: an integer, a float that we already know, a string that we initialize with the string entagma, and a vector. And initializing or setting a vector to constant values, that means when not using individual variables for the individual vector components, works with the curly bracket syntax. So the first number would be my x, the second number my y, and the third number my z component here. And that's how you declare and initialize the most basic variable types. Back to our example, let's head into this point wrangle and try to initialize some variables here, and maybe try to provoke some error messages as well. So the standard way of declaring and initializing a variable would go like that. Let's create a float variable, let's call it scaling, and let's initialize it to 0.0. And you notice me using this point notation here. What I could also do in this case, and Vex would do exactly the same, is write it like that. However, in certain other languages, this could result in an error message, as this, technically speaking, is an integer, a whole number, and not a floating number. So let's stick to that. This is a rather common source of errors, for example, when writing OpenCL. Also, let's initialize an integer called count, and let's also initialize it to 0, and in this case, write the 0 down as an integer. So that worked. Let's try to provoke an error message by maybe declaring another integer. Let's call it error and set it to 0 again, and try messing with the name. So for example, let's try and start the variable with a comma instead of a letter of the alphabet or the underscore. We can see now we immediately get this error message. We get this wavy line underneath our comma, and when we hover over here, we can see we get a syntax error that we have an unexpected comma here. Let's delete it. Also, I'm not allowed to start my variable name with numbers, so let's call my integer 123 error here, and we can see we again get an error message. When we hover over it, again we get a syntax error telling us that we need to delete these numbers here. Also, let's try using some special characters, for example an exclamation mark, and that too yields an error. However, what I can do is start this one with an underscore, that is perfectly legal, or use numbers anywhere else in my variable name, except for at the beginning. You can see this works. So what's perfectly feasible is something like error01 or error underscore 01, like this. When it comes to choosing names for your variables, it makes sense to keep them as short as possible while still being easily understandable. So for example, take this variable called count. While it would be very explicit to call it something like, this is where we count how many points there are, it would be very cumbersome on the one hand to type this. On the other hand, it would make your code extremely difficult to read. So rather stick to something short and concise, in our case count, and also on the other hand shortening this down, like for example let's call it CT. While admittedly this is very quick to type, as soon as your code gets bigger, it makes it very hard to read again because you constantly have to look up what this variable means and provide annotations for what this variable means. So again, stick to something that most people will understand and that will make sense to most people, including you yourself. Also, when it comes to compound names, so let's for example call this one point count, there are two different schools out there. The one thing that you could do is divide this with an underscore, and the other thing that you could do is do something called camel case. Like this, where separate individual words with capital letters. And I started out using this underscore syntax, yet nowadays I'm mostly converted to camel case, but again, that's up to your taste. Now, let's delete all this and create a new variable called test and set it to 0. Now, let's assume we want to add 1 to this variable for whatever reason. The syntax for doing that is like this. Test equals test plus 1. So my new value of test is the old value of test plus 1. Let's check this by just writing it down on our points. So let's create a float attribute, an integer attribute called test, and it's the same value as my variable test. Let's just highlight this, head to our geometry spreadsheet, and we can see now my test is 1. Let's just copy this line a second time, paste it here, and it's now 2. Because we added 1 2 times. However, what is not possible is writing something like this, test plus 1. While this might not yield an error message, and might even perform some calculation, it does not update my variable. So while I'm adding 1 to the current value of my test variable, I do not store the result of this calculation somewhere in my RAM. And thus, the value of my variable test does not change. So keep in mind, it's always this syntax if you want to actually add, subtract, divide, or multiply something with your variable, and then store the result in your variable. So you'll be able to use it further down in your code, which is what you usually want. Let's change this to a float, and the attribute as well, so we can now see we have now a float value here. And what we of course can also do is divide our variable by something, so let's divide it by say 7, and we can see now here the result. So we now have a calculator at our hands that is really clumsy to use. Of course, other basic math works the same, so multiplication works like this, test equals test times 14. We can see now we have a value of 2. And finally, let's do some subtraction here. -4. We now have a value of -2. However, when you look at this, this looks a bit clumsy. You write test equals test and then the actual operation that you want to do, which admittedly is lots of typing for just incrementing, decrementing, multiplying, or dividing a variable. That means adding to a variable, subtracting from it, dividing it by some value, or multiplying it by some value. And there's a shorthand for this here. So let's delete this when I look at the addition, like this, there's a shorter way how I can write this. I can write down test plus equals 3. And this line of code and this line of code do exactly the same. So the plus equals syntax means the same as take this variable and add to it 3, which is exactly the same as this line here. Also, this, of course, works with subtraction, it works with multiplication, and it also works with division. And that is my preferred method of doing basic math on a variable.